Yeah, I wanted to say on op amps, like the 5532 that have these pesky input diodes, that, like I said in the previous video on the 5532, you really can't use it as a differential amplifier unless it's only zero point 0.6 volts. Now, they'll talk about, having input resistors on these things, so that, you don't blow the diodes out by having too big of a voltage. Okay, that leads you to believe that you can use them as a differential amplifier, but you really can't. You're still limited to zero point 0.6 volts, just because, you won't have too much current going through it. It still is limited to zero point 0.6 volts generally. So, and some op amps that have these kind of protection diodes in them actually, insist that use a feedback resistor, even when you're setting it up as a unity gain amplifier, just because the op amp, some op amps can actually literally burn their own input diodes out. If you set it up with just a shunted unity gain, where the output goes directly to the inverting input terminal, and then it's a voltage follower basically. Um, they insist that you put a resistor in there just to protect those diodes for the most part. You know, um, so it doesn't burn its own diodes out. And as a case in point, at unity gain, normally you wouldn't have to worry about that. But as the frequency increases and you start running into slew rate limits, well, it's possible you got like a 3-volt input signal here, right? Well, it's a propagation delay from the input to the output, so it can take that output a while to swing versus the time your input swings. So inadvertently, basically you can start putting current through those diodes. And you will, because there's an actual delay, a phase delay. So you could end up with a volt or two, between the negative terminal and the positive terminal activating these diodes. And if you have no resistor protecting them, the thing, if it's got enough oomph, it can burn out its own diodes. And again, the higher the frequencies and so forth, and the higher your input signal, the higher your slew rate, because it doesn't even have to necessarily be a high frequency. If you just have too high of a slew rate input, like a very fast transient square wave in it, you can see a delay, a brief delay in between the input and the output, even like 10 hertz. And then, but have there be a big enough voltage on here to burn out your diodes potentially. It'll be a very brief transition, but again, some op amps, they just can't handle that. So, that's why you'll see in some data sheets. That's why it's always good to read the data sheets and the fine print too, to make sure if you got an op amp with diodes in it. But always look for those damn diodes, because again, they can cause other problems too under some circumstances, I guess. But just always look for them, and generally try to avoid those, op amps with those diodes if you can, because they are pretty, they're a liability, and you can't really use it as an actual differential amplifier for anything bigger than, half a volt or so. So, if that. So, anyway, cheers.